Hello guys, good evening. This is the Group 5 and our report is all about different types of rain gauge and estimation of missing rainfall data. I hope you enjoy and relax as you will learn about different types of rain gauge. There are two types of rain gauge, a non-recording rain gauge and a recording rain gauge. Number 1, a non-recording rain gauge. It is defined as the gauge which is read manually. It doesn't record rain itself, but simply collects. Number 1 example is a Simon's rain gauge. It's the most common type of non-recording rain gauge. The collector is used above the funnel leading into the receiving vessel. The rainfall is collected in the vessel is measured by a graduated measuring cylinder or dipstick to give a depth of rainfall. This type of rain gauge gives the amount of rainfall only. Such rain gauge does not provide the information regarding the time, intensity, and duration of the rainfall. The capacity of measuring glass is 25 mm and the least count is 0.1 mm. Secondly, a recording rain gauge. Number 1 example of recording rain gauge is a weighing bucket rain gauge. It is the most common type of self-recording rain gauge. A tipping bucket rain gauge is a relatively simple mechanism used to measure a rainfall. It is the most common variety of rain gauge due to its ease of use and reliability. Great for use in stable and unobscured location. And here is Mr. Brian Jastram, a monitoring and instrumentation specialist, and he will explain to us the parts and how the tipping bucket rain gauge works.
The top part is the funnel with a screen. Below that, you can see where the funnel comes down and one of the heating elements that makes it a heated tipping bucket rain gauge. Inside there's another heating element around the edge, and there is the tipping bucket. The funnel directs the precipitation into the tipping bucket, and the tipping bucket fills and then overflows as it tips. Every time the tipping bucket tips, a magnet goes by a reed switch, which creates a momentary contact closure. And that contact closure signal comes out through these two white wires and travels down this wire into a pendant data logger. So this data logger records every tip, every closure from that reed switch, and then also the time, temperature, and voltage of the data logger battery. You can connect your power source to these wires on the side, and there's an internal thermostat that keeps the heated rain gauge at the right temperature to melt snow and ice. With this data logger, we use a shuttle to collect the data. Once a month, we visit each rain gauge and insert the pendant data logger into the shuttle and press the switch to transfer the data to the shuttle. Once it's done blinking and gives us a green light, we can take the shuttle back to the lab and transfer the data from the shuttle to our computer. We have 5 of these rain gauges. 4 are deployed in the field right now, and we've put them in kind of a localized area so that we can see the rainfall pattern in a small area, how much it varies. So if in the metro area you get a 1/4 inch of rain, and in our small rain gauge network you get in general a 1/4 inch of rain, we might get 0.2 inches here and 0.27 here, so we kind of want to see how variable the rainfall patterns are. So that's what we're using this network of rain gauges to collect data for.
gauge. It is a type of instrument used by meteorologists and hydrologists to measure rainfall rate in a certain period of time. Rain gauge are also known as odometer, pluviometer, and ombrometer. And there are two types of rain gauges, non-recording type and recording type. Example of non-recording type rain gauges is Simon's rain gauge. Non-recording type rain gauge is most common type of rain gauge used by meteorological department. It consists of cylindrical vessel 127 mm in diameter with a base enlarged to 210 mm diameter. And its top section funnel is provided with circular brass rim, which is 127 mm exactly so that it can fit into vessel well. Floating or natural siphon type rain gauge. The working of this type of rain gauge is similar to weighing bucket rain gauge. A funnel receives the water which is collected in a rectangular container. A float is provided at the bottom of container, and this float raises as the water level rises in the container. Its movement being recorded by a pen moving on a recording drum actuated by a clockwork. When water rises, the float reaches the top floating in water. Then siphon comes into operation and releases the water outwards through the connecting pipe. Thus, all water in the box is drained out. There are three types of recording rain gauges: weighing bucket type, tipping bucket type, and floating or natural siphon type rain gauge. Weighing bucket type rain gauge is most common self-recording rain gauge. It consists of a receiver bucket supported by spring or lever balance or some other weighing mechanism. The movement of bucket due to its increasing weight is transmitted to a pen which traces record or some marking on a clock-driven chart. Weighing bucket rain gauge instrument gives a plot of the accumulated rainfall values against the elapsed time, and the curve so formed is called the mass curve.
Hi guys! So ngayon, pag-uusapan natin ang tungkol sa arithmetic mean. So ano nga ba ang arithmetic mean? One method is to calculate the arithmetic mean. To do this, add up all the values and divide the sum by the number of the values. Dito ay gagamit tayo ng formula na a plus b plus c over n. Take note lang na ang ating a plus b plus c ay ang ating observation. At ang n naman ay ang ating total number of observation. Para naman makuha ang ating total number of observation, kailangan lang natin bilangin ang ating observations o ang ating value. Para makuha natin ang ating mean, kinakailangan muna natin hanapin ang ating average of observation. At para malaman ang ating average of observation, kailangan lang natin ipag-add ang ating value o ang ating observation. Kapag nakuha na natin ang ating average of observation, i-divide lang natin ito sa total number of observation at saka na natin makukuha ang ating mean. Halimbawa na lang sa problem na ito. The mark obtained by 6 students in class test are 20, 22, 24, 26, 28, and 30. Find the mean. Gamitin lang natin ang ating formula na a plus b plus c over n. Ipag-add lang natin ang ating value o ang ating observation na 20 plus 22 plus 24 plus 26 plus 28 plus 30 at saka na natin makukuha ang ating average of observation. At kapag nakuha na natin ang ating average of observation, i-divide lang natin ito sa total number of observation at saka na natin makukuha ang ating mean. Diba? Napakadali.
Normal ratio method. Normal ratio method is used when the normal annual precipitation at any of the index station differs from of the interpolation station by more than 10%. In this method, the precipitation amounts at the index stations are weighted by the ratios of their normal annual precipitation. data in a relationship of the form. So, ayan po yung formula for normal ratio method. Px is equal to 1 over n summation of nx over ni times pi. So, example po for normal ratio method. Find out the missing storm precipitation of Station C given in the following. So, Station A, B, C, D, and E. Storm precipitation, Station A 9.7, Station B 8.3, missing po sa Station C, and then D 11.7, Station E 8.0. And for the normal annual precipitation, Station A 100.3, Station B 109.5, and sa C 93.5. Letter D 125.7, Station E 117.5. So, paano naman po ma-determine if normal ratio method ang gagamitin or arithmetic mean? Need lang po ng 10% addition and subtraction for annual precipitation of Station C. Example po is 10% of NC is equal to 93.5 times 10 over 100 is equal to 9.35. So, addition of 10% of NC is equal to 93.5 plus 9.35 is equal to 102.85. And for the subtraction naman po, ang makukuha natin is 84.15. So, after that po, need po natin i-check if yung value po ng normal annual precipitation ng Station A to Station E is hanggang sa range lamang po ng 84.15 to 102.85. So, dahil naman po makikita na lahat ng value po, bawat station ay lumagpas po doon sa range, ang gagamitin po natin formula is normal ratio method. Px is equal to 1 over n summation of nx over ni times pi, where n is the number of nearby stations, pi is precipitation at ith station, px is equal to missing precipitation, ni is the normal annual precipitation, and nx is for normal annual precipitation of missing station. So, from px is equal to 1 over n summation of nx over ni pi to px is equal to 1 over number of station times nx over ni times pi plus nx over n2 times p2 plus nx over n3 times p3. So, px is equal to 1 over 4 times 93.5 times 9.7 over 100.3 plus 93.5 times 8.3 divided by 109.5 plus 93.5 times 11.7 divided by 125.7 plus 93.5 times 8.0 divided by 117.5 is equal to 7.8.
Yan, so welcome ulit sa ating hydrology class. So, ang gagamitin nating method ay yung tinatawag natin na inverse distance weighting method. So, ito yung equation niya, no? So, rainfall estimate dito sa ungauge site is equal to the summation of PIWI divided by the summation of WI. So, P natin dito is yung mga recorded rainfall from a known rain gauge. So, yung I dito is subscript. Ibig sabihin parang notation lang na kunwari rain gauge 1, rain gauge 2, rain gauge 3. Ito namang N is total number of rain gauges. P is the recorded rainfall, and then W natin is yung weight. So bali bibigyan natin ng weight yung bawat isang known na rain gauge. So, yung bawat isang recording rain gauge bibigyan natin siya ng weight. So yung weight natin is ano yung influence niya dun sa ungauge site natin. So, ang weight is calculated as W equals 1 over D square, where D is the distance from the ungauge site to the gauge site. Okay. So, kung makikita nyo dito, yung weight natin is naka 1 over d square. Ibig sabihin, 1 over d square, pag malayo yung rain gauge mo dun sa ungauge site natin, kung malayo yung reference na rain gauge, ibig sabihin, maliit lang yung influence niya. No? Maliit lang yung influence niya dun sa ungauge site natin. So, yun yung ibig sabihin nito, 1 over d square. As d increases, liliit yung W. So, ibig sabihin, kung sobrang layo na, kung meron kang dalawang ranges, i-compare mo, tapos yung isang, for example, meron kang unknown, tapos meron dalawang rain gauges, RG1 at RG2. RG2 natin is 100 kilometers away from the ungauged site, tapos yung RG1 is 50 kilometers away from your ungauged site. So, mas malaki dapat yung influence ng 50 kilometers lang compared sa 100 kilometers. So, yun yung ibig sabihin ng weight natin. So, okay. So, diretso na tayo na example. Dun sa field sensor na pinakita natin last time, marami actually present na rain gauges na itong mga blue. Ito yung mga recording rain gauges natin, automated rain gauges na andun sa website natin sa field sensor. No? So, ito yung ganito karami yung existing sensors natin nationwide. Tapos itong area naman ito, itong maliit lang na box dito. No? So, which is somewhere in Northern Mindanao. Okay? Northern Mindanao, Cagayan de Oro. So, ito yung mga municipalities. Somewhere dito is Iligan, somewhere dito is Cagayan. So, yan. Ito yung mga rain gauges na currently installed and working and operational. Recording rain gauges. Okay. Example natin, what if gusto mong malaman yung rainfall dito? Gusto mong kumuha ng data at this particular point. So, walang gauge dito, walang rain gauge. Ibig sabihin, kailangan mong i-estimate kung anong rainfall dito based dito sa data ng mga present natin na rain gauges. Okay, so we have ARG1, 2, 3, 4, and 5. So, meron tayong 5 rain gauges available sa area. And then, ito yung mga distances nila with respect to your ungauged site. So, yung ARG1 is 30 kilometers, etc., etc. Pinakamalayo dito is yung ARG3 natin, which is 33 kilometers from your ungauged site. So, paano natin i-apply yung equation kanina? Una is compute natin yung weight per rain gauge. So, for example na lang sa ARG1, weight ng ARG1 is 1 over D1 squared. Determine na yung distance natin, which is 30 kilometers. So, 1 over D1 squared, so 1 over 30 kilometers squared. Yung weight natin is 0.00111. So, yun yung weight natin. So, same with the other rain gauges. W2, for example, equals 1 over D2 squared lang. And then W3 equals 1 over D3 squared, etc., etc., etc. Sa pagkuha naman ng ating rainfall dito sa ungauged site, ito yung susundin natin na equation, yung kanina. So, medyo nakakatakot tingnan, pero actually, madali lang naman yan. Isasama mo lang yung product ng P1W1 plus P2W2, P3W3, divide mo dun sa W1 plus W2 plus W3, etc. So, magiging ganito yung equation mo. So, pagkuha mo ng rainfall sa ungauged, ito yun, summation of PIWI from I to N. So, yan. Ang N natin dito is 5 kasi 5 rain gauges. And then, we have P1 or PI, P1, 2, 3, 4, 5, and W1, 2, 3, 4, 5. Denominator naman natin is yung summation lang ng W. Okay? So, makakuha mo na ngayon yung P ungauged. Okay?
This is our report for today. Thank you.